Hi, and welcome to the Grafana Alloy for Beginners series. My name is Mischa Thompson, and I'm a senior software engineer at Grafana. In prior episodes, Lisa covered Alloy fundamentals and how you can build pipelines for infrastructure metrics and logs. In this episode, we will shift gears to application observability and cover how we can build a pipeline for application metrics with Grafana Alloy. These episodes build on one another. Before starting this episode, make sure you've watched episodes 1 through 8 and completed Alloy configuration sections 1 through 3 in the series repo. We saw this slide earlier on, but to recap, our mythical server, requester, and recorder each expose a /metrics endpoint and are trying to send logs and traces to Alloy. Our next few sections will be to start scraping those applications and receiving the telemetry they're sending us. To get started, open the Grafana Alloy for Beginners repo and scroll down to section 4. As a quick reminder, each section starts with starter code, then tasks to explain the config and what you'll need, and finally a solution with the finished version. Next, I'm going to go over the pipeline we'll be building visually and then walk through the solution. I'd encourage you to copy the starter code into config.alloy, try it yourself, and compare with the solution when you're finished. If you haven't already, start up the learning environment and open config.alloy. Here's the pipeline that we'll be building today. To begin, we will start scraping Prometheus metrics from our mythical server and requester using the prometheus.scrape component. The scrape component will forward metrics to a recently added experimental component, prometheus.write.queue, which will send our metrics to the locally running Mimir. This component performs the same function as prometheus.remote.write, which we saw in sections 2 and 3, but includes a revamped write-ahead log that comes with some performance enhancements. Note that while we're using this for the demo, remember to stick with prometheus.remote.write in production until this component is officially stable. But now you know an exciting upcoming improvement. As we've done before, we'll use a prometheus.scrape component to collect metrics. Where before we used service discovery to find which targets to scrape, we'll be defining them manually in this example. Doing it this way helps us see exactly what targets look like under the hood, and it's also a perfectly viable approach when you have a small static set of services that you want to monitor. An individual target is defined as an object in Alloy configuration, which is really just a collection of key value pairs. They are similar to a map, hash, or dict depending on your previous experience. Targets have a few special values that can be used to control scraping behavior, like the scrape timeout, query parameters that should be included in the request, individual scrape intervals, and more. These control values always start with a double underscore and will be dropped before being forwarded to other components in the pipeline, so they will not be added as labels on metrics. The only required field for a target, and the one we'll be using today, is the double underscore address value. This defines the network location of the machine or service you'd like to collect metrics from. Any non-double underscore key value pairs will be added as labels on metrics for that target. So we're going to configure our scrape component with two targets, one with the address for the mythical server and another for the requester. We'll also be adding a group label to both with the value of mythical and a service label with the value of mythical server and mythical requester, respectively. Moving on to the prometheus.write.queue component, which is where we're going to forward our scraped metrics to, it really operates the same as the prometheus.remote.write that you've seen before. One notable difference is that the endpoint block is now named. We've named ours Mimir here, and we've configured it to send metrics to the locally running Mimir instance. Once you've finished setting up your config, don't forget to reload the configuration. Once you're finished, scroll down to the verification section, click on the dashboards link, go through to section 4 verification, and you should now be able to see requests coming through for all of your different mythical services. In this episode, we started collecting application metrics from our mythical server and requester. In the next episode, we will build a pipeline for application traces with Grafana Alloy.